Oh yeah, sorry. So listen very carefully. Yeah. So as our neodymium, and one side is south, but I'm not sure which because it doesn't say. So, but I can find out which in a moment. We're going to find out. Now, what I've got here is a supply which is supplying current that's going to go this way because that's positive and that's negative. So positive conventional current goes this way. So if the current goes in this way, it's going to flow along here and round there. So let me just turn the light out so we can see hopefully a little bit clearer. Like that, it's nicer. Okay, so watch. The conventional current is flowing along here and it can flow through this wire and back again. And this can move. But that means the conventional current is going to be flowing that way. So I do know that. Now, I don't know which way the magnetic field is, but it's certainly either directly upwards, coming from a north pole, or it's pointing downwards going towards the south pole. I don't know which. We're going to find out which using Fleming's left-hand rule in a moment. So I know that there's going to be a force on this wire, and I know it's going to be left or right, because what we know is we know that the force, the field, and the current are mutually perpendicular. And it just so happens we can hold our thumb and first two fingers in this mutually perpendicular manner, so it's quite convenient. But I know the force is going to be this way or it's going to be that way, but I don't know which unless I use Fleming's left-hand rule to figure it out. Now let's observe which way. Now switch this on and hopefully it's going to move. Oh yeah, I'll move it there. See? When I put it there, it comes back that way. So the force is on the image there is to the left. Yeah? It's forcing it to the left. Get sticks of it. There we are. So the force is to the left, so I can do force to the left in conclusion. Right. And they're perpendicular. So if I move it there, it comes back again. Okay, that's the motor effect. Now, Fleming's rule says that, right, the fields, therefore, must be mutually perpendicular to those two, so it's got to be either up or down. But I don't know which, what, 50-50 guess, isn't it? But no, because Fleming's left-hand rule, we could do away with 50-50 guess, and we know that we put our left hand like this. Then we say the force is the thumb, the magnetic field is the first finger, B field. Say B for magnetic fields, for some reason, that's the way it is. B field, FBI, okay? And I is the current. There we go. So that's easy then. All I need to do is line up my hand. Now, so force, contortions, force is this way. B field, I don't know this one yet. The current, I do know is that way. Oh, we've got to turn the hand over. Like that, and my finger, you can just see, is pointing downwards, and that's the B, isn't it? And it's pointing downwards. So I've lined up the other one, my finger's pointing down, so that means the B field is going to go downwards. I can do an X and say that's the B field there. So Fleming's left-hand rule, all it's done is got round a 50-50 guess as to which direction that field was. Turns out it's, oh well, if that field is downwards, if that's the B field, downwards, then which pole of the magnet are we looking at? South, because south, the lines always point towards the south pole, don't they? So we must be looking at the south. So I can conclude that this is indeed a south pole of the magnet. I can also reverse the current. So if I'm just changing the poles round on here, like that, so I'm making that one positive, and now guess what's going to happen now? It's still a south pole, but look, it's going the other way it's getting hot. It's burning my fingers because the current is so large. So we've reversed the force because we reversed the current. So that one is the other way. Now that one's the other way, the force is the other way. But Fleming's left-hand rule still predicts it correctly. I could turn the magnet round and guess what's going to happen? When the north is facing upwards, where's the wire going to go? Back. And Fleming's left-hand rule again predicts correctly all of the force, the B field, and the current. Any questions on that? So what you're going to do is you're going to have a go at drawing like I did. You have to draw with your right hand, and draw it. Now I'm going to give the Leonardo da Vinci eyes so you can draw it really well. If you're a left-handed person, you're going to have to draw with your right hand, your left hand. Then my sympathies to you. You're going to have to try that. It's fun trying. Any left-handers in here? Yes, one of you is. Okay.